We are going to calculate the molar concentration of NaOH, or sodium hydroxide, given that the pH is 12.00. So we can solve this problem in two main steps. The first is to write out the balanced equation. Since NaOH is a strong base, it is going to dissociate 100% in an aqueous solution. So we have NaOH as our solid. Our products are Na+, or the sodium ion, a cation to be more specific, plus our OH-, or our hydroxide anion. Notice how I put a 1 in front of everything, and that's because the reaction is already balanced as is, and everything exists in a 1:1:1 mole ratio. The next step is going to be solving for the concentration of the hydroxide ion specifically. And the reason why we can do that is because if NaOH dissociates entirely, that means that the concentration of OH- must be equal to the concentration of NaOH. We are given pH. In order to get the concentration of OH, or NaOH, we would have to first convert pH to POH. From there, we can convert POH into the concentration of OH, which will then give us NaOH concentration. In order to find POH, we can use this equation. pH plus POH is equal to 14.00. So when we plug in the given information, we could rearrange and solve for POH by subtracting pH from 14. So we get POH is equal to 14 minus 12, which is 2.00. The next step is to solve for the concentration of OH given POH. We could do that by setting the concentration of OH equal to 10 raised to the negative POH value. So the concentration of OH is 0.010 molar. Again, since we know that a strong base is going to dissociate 100%, the concentration of the product OH- is going to be exactly equal to the concentration of NaOH. The concentration of NaOH must be 0.010 molar.